Welcome back and thank you for joining me. Today we're moving into section 1, roots and radical expressions. Our goal for today is we're going to be talking about how to find the nth roots of numbers and variables. This is something you started back in Expo and now we're just going to take it to the next level. So there's more than just square roots, okay? A square root undoes squaring. So 5 squared gives you 25, meaning the square root of 25 will bring you back to the 5. 5 cubed gives you 125, so the cube root of 125 will bring you back to the 5. So every power that you've learned has an opposite, a root that will get you back to the number that you originally took the power of. Some key vocab that I need you to know. The index. The index is basically the power, okay? The index is what root are you taking? Is it a square root, a cube root, a fourth root? So that's what I mean when I say index, okay? Radical sign is pretty obvious, is just the symbol. And then the radicand is whatever is inside the radical sign, okay? So again, just some key vocabulary, so when I'm using these words throughout this chapter, you have an understanding of what I mean. So, the nth root, okay? So this is pretty wordy in the key concept. So I tried to summarize it underneath it. So there's two important things to know about the nth root. It can be odd, so cube root, fifth root, seventh root, or it can be even, a square root, a fourth root. So what it's saying is when you're taking an odd root, okay? An odd root, you just get what you get, okay? You basically, whatever your calculator would give you, that's your answer. Now, an even root, something special happens here. For example, you know, back in chapter 4, if we were to solve this equation right here, when I go to square root it, if you square root in an equation, remember you always get the plus or minus. It's something that I hounded back in chapters 4 and chapter 5. Well, the interesting thing is that happens anytime you have an even root, okay? If you're dealing with a fourth root, if you're dealing with a sixth root, that actually always ends up happening, okay? You always end up getting the plus or minus. So that's something you have to keep in mind. So when it's written in words, okay, like these examples right here, when I'm telling you, find all of the real square roots. Whenever it's written out in words, I want you to think back when we did the equations. If you're taking an even root and it's expressed in words, you need the plus or minus. So square root of 169. Now this is something, if you don't know it off the top of your head, this is something your calculator can do for you. Square root of 169, and it'll tell you 13. Okay, but of course, because it's even, it's really plus or minus 13. You're taking an even root. Okay, 196. Again, let's say you don't know it. 196, you get 14. But of course, you're taking an even root, so it's plus or minus. Now, remember though, look what happens if you try a negative number. Oh, it is not happy. Remember, you can't take the square root of a negative number. It's not real. Okay, now the same thing actually happens for every even root. Okay, any even root, if you try to take it of a negative number, you get no real solution. Okay, again, that is every even root. And the cool thing is in this chapter, we're not going to be dealing with imaginary numbers at all, okay? All the numbers we're dealing with are going to end up being real numbers. So when this is the case, you can just put that there's no real solution. Cube roots. So now cube, you're taking an odd root. So this one you legitimately get just whatever you get. So cube root of 64. Now this is something that may not come so naturally to you, something you may not know. Well, you can always use your calculator to help you. If you go into the math menu right there, notice it has the cube root for you, okay? Cube root of 64, and it gives you 4. So what that means is 4 times 4 times 4 gives you 64. 125. Again, you can go to the math menu. 125. Hit enter. That one's 5. And negative 216. Now, here's the kind of cool thing, is notice when I have an odd root, notice I can actually get answers, okay? And the answer is going to be odd. The answer is going to be the same sign as the number you originally put in, okay? So this one tells you negative 6 times negative 6 times negative 6 is negative 216, which makes sense because you know that third negative is going to make it negative again. So hopefully that makes sense to you. And this is something that your calculator can help you with. Now, throughout this chapter, though, I'm going to introduce you to a helpful little guide, okay? Something you actually get to use on the test when you get there. And it is this powers chart, okay? So this power chart is going to be very, very helpful to you. In fact, probably more helpful than the calculator. And I'm going to show you how to use it. And again, you'll be able to use it on the test. So here, this is one you've already seen. Square root of 169. Now, let's say you don't know it. I'm going to show you how to use this power chart. So whenever it's not written, that index is going to be 2, all right? So what that 2 means is I'm functioning in the second power, okay? So I'm going to be looking down that column, and I'm looking until all of a sudden I get the 169. I see that it's there. Your solution is whatever number is back here. Okay, now, if it's already written out in a square root, then don't worry about pluses and minuses. That's only if it's written in words that you treat it like an equation. If it's just written out, just do whatever it says, okay? That's something I know students have a hard time remembering, wrapping their minds around, but if it's already written in a square root, just do it, okay? Don't worry about the pluses or minuses. That's only if it's from an equation or when it's written out in words. All right, so what about the next one? So let's continue looking at this. So this time I have a third power. So that means I'm looking in this column, okay? The index tells you which column to look in, and then I scroll down until I see, oh, there's the 512, okay? It's actually in the chart. What's the answer? Well, the cube root of 512 is 8. But because of that negative there, it actually ends up being a negative 8. Remember, when you're taking an odd root, the answer is the sign of the number that was inside of it, okay? And let's say you have a fractional one. Well, a fractional one, you can just take each piece independently. This 4 is going to be looking in the fourth power. The fourth root of 16 is 2. And the fourth root of 625 is going to be 5. Okay, so this chart is very, very powerful, very, very helpful for you when you learn how to use it. And it gets even more helpful in the future lessons where the radicals don't turn out to be so nice, where the number isn't in there. It's very, very helpful to have. All right, so that's just a little introduction on how to use that powers chart. Now that we know how to use numbers or do radicals of numbers, now I want to have a conversation about exponents. Okay? So when you're dealing with an exponent, or with a variable, I should say, we have some additional rules. So again, I'm going to be talking through all of this. Everything I'm about to do is laid out right in there. So if at any point you lose track of why I'm doing what I'm doing, just go back, look in there, and you'll be able to see what step I'm on and what the next step is going to be. So the first thing is I look at the root. This one is a root 2, okay? So because it's a root 2, I'm going to identify this is an even root, okay? So even roots have some special things that we need to do, all right? Now, taking the number, the square root of 16, well, that should be obvious. But again, if you need help, we're talking about a second root, 16. So that's going to be the number 4. All right, so I know I'm getting a 4 out here. And in terms of the exponent, okay, in terms of that, x to the 8, well, you're going to see how many times can 2 go into 8? Well, 2 can go into 8 4 times, right? 2 times 4 is 8. So on the outside of the radical, it becomes x to the 4, because that's how many times the index went into the exponent, right? So now, because it's even, we had to guarantee that we're dealing with positive things. Because remember, you couldn't take the square root of a negative. So we have to be careful that we're only dealing with positive things. So only when it's an even root, you need to slap on absolute values. Okay? However, we need to process through a number never needs to be inside the absolute value, okay? Because when it comes out, it was going to be positive anyway, so that didn't matter. Okay, so anytime you have a number there, you don't want to write it inside the absolute value. And I'll think about x to the 4. If I'm taking something to the 4th power, if I'm taking something to an even power, it's automatically going to be positive anyway. So in that respect, the absolute value isn't really needed, okay? Because any number to an even power is going to be positive anyway, and that's all the absolute value does. So you have to show that you thought about it. Show, I know I need absolute values there, but then in this instance, you actually get to take everything out of it. Everything was going to be positive anyway, okay? So I know that seems a little convoluted, a little bit odd. As I step through more examples, I think you'll get more used to it and understand it better. Here, this one, I'm taking an odd power. So the cool thing about odd powers, you don't have to worry about the absolute value whatsoever, okay? It's not going to be important. You don't need it. So I'm dealing with a cube root. So in this case, cube root of 27. So cube is the 3rd power. 27 is going to give me 3. So here, this is going to be a 3 outside the radical. How many times can 3 go into 6? It goes in twice. And how many times can 3 go into 9? 3 goes into 9 3 times. So it comes outside of the radical looking like that. And again, you don't have to worry about absolute value because it was odd to begin with. So you don't have to worry about it. All right, the next one, a 4th root. The 4th root, well, that's even again. So now everything I do, I am going to have to put in an absolute value. 625. So let's look up here. 4th root of 625, that's going to be 5. So 4th root of 625 is 5. 4 goes into 8 4 times. Oh, I'm sorry, not 4. 4 goes into 8 twice. 4 goes into 12 3 times. And this is the case. It's even, so we need to consider the absolute value. Now let's run through this. The number 5 is guaranteed to be positive anyway. Doesn't need to be inside the square root or the absolute value. X squared, if you square any number, automatically guaranteed to be positive. But now, that y to the third, an odd power, something taken to an odd power could be negative, but we have to guarantee that it wasn't because it was inside of an even root. So because its power is odd here on the outside, it needs to stay inside the absolute value because I need to guarantee that what I have there is positive. Okay, so that's the instance where the absolute value matters, is when once you pull it out, if it's an odd power, now you have to guarantee me that you're dealing with a positive value. Okay, so that's where this starts becoming really important that you do that step. Now, I'm going to do this a couple more times for you just to make sure that everything's making sense. So here, this is a square root, even. That means I'm going to have to be concerned with absolute value. Square root of 81. The square root of 81 is 9, and of course you could have used the table for that, the powers chart. 2 goes into 4 twice. So on the outside here, that's going to be x to the 2. Now, because it's even, we have to consider the absolute value. However, if you examine it more carefully, 9 is automatically positive. It doesn't need the absolute value to guarantee that. And x squared, anything to an even power, is also guaranteed to be positive. So you don't actually need the absolute value at all here. You can just leave it off. Let's look at my next one. So here, this time, I'm dealing with an odd power, okay? 3. So what's the cube root of 8? Again, if you don't know it off the top of your head, let's come back here. Cube root means I'm dealing in this column. 8, the cube root of 8 is 2. So I have a 2 here. How many times can 3 go into 12? Well, 3 times 4 is 12. How many times can 3 go into 15? Well, 3 times 5 is 15. And of course, this one is odd, so I don't have to be concerned with the absolute value. You never have to worry about it if you're dealing with an odd root. For this next one, we're back to an even root again. So now we're going to have to be concerned with it. The fourth root of 16, well, again, if you don't know off the top of your head, let's look at this. So fourth root of 16 is going to be 2. 4 goes into 12 3 times. 4 goes into 16 4 times. Because it was even, I need to consider my absolute value. So, looking at this, the number 2 is automatically going to be positive. So I don't have to worry about that, okay? Y to the 4, again, anything to an even exponent is already guaranteed to be positive. The thing that is not guaranteed to be positive is at x to the third. So because that odd exponent does not guarantee me a positive value, it has to stay inside the absolute value. Okay, so again, that's a process of how you know when you can pull things out of that absolute value. So really quickly, let's look at a word problem before we wrap up for the day. Some teachers adjust test scores when a test is difficult. One teacher's formula for adjusting scores is A equals 10 to times the square root of R, where A is the adjusted score and R is the raw score. If the raw scores on one test ranged from 36 to 90, what is the range of the adjusted scores? Okay, so these are both R values. Those are the raw scores. So we're talking about 10 square roots of 6. Oh, I'm sorry. Kind of just gave away the answer there. 10 square roots of 36 to 10 square roots of 90. So now we need to look to see how are these going to actually correlate to numbers, because that really doesn't mean much to you. Well, you know the square root of 36. You know the square root of 36 is just 6. So the person scoring a 36 would score a 60. What about the person that already scored a 90? Well, 10 times the square root of 90, that's not a nice number. So what I would do, I would just plug that in to my calculator. 10 square roots of 90, that person's now going to score a 94.9. Okay? So that's how you can do your adjusted scores. Just plug it in, and this would be the range of values that the students would get based on those adjusted scores that the teacher is going to use. Right, thank you so much for joining me for this. Now, if you'll notice here, starting here, because now this is new material, I do have this summary. Those of you who had me first semester, you already know what to do. Those of you that have not had me, why don't you wait? And I'll kind of show you what my expectations for that summary is, okay? We'll kind of make one together, and I'll model it for you so you know what my expectation is as you're doing the summaries throughout the rest of the course. So for now, thank you for joining me. You can kind of wrap up. We're done with this lesson, and then come back ready to show what that summary looks like and to do our practice work together.